Sometimes when we have redox reactions in aqueous solutions, they can be difficult to balance using the technique we've learned, which is balancing by inspection. During the break, I'll dig up one that's really, really challenging, and we'll look at how this method can help us to do that. It's called the half reaction method of balancing. And it is much better for some of these more complicated redox reactions. The idea here is that we take the overall reaction and we break it into two parts. They're called half reactions. So we look at the thing that's being oxidized and we look at the thing that's being reduced separately. We balance those reactions individually and then we add them back together and we end up with a balanced overall reaction. So let's look at how we would do this. Let's look at this redox reaction. So here we have aluminum plus silver ion is forming aluminum ion plus silver. There are two things that need to be balanced. We need what's called mass balance, the same number of atoms of each element, but we also need charge balance. This equation is already mass balanced. There's one atom of aluminum on each side and one atom of silver on each side. But on the left we have a +1 charge, and on the right we have a +3 charge. And that's out of balance. So the first thing we do in doing this half reaction method is we assign oxidation numbers to each of the atoms in the reaction. So what's the oxidation number for the aluminum on the left? 0. It's just all by itself. And what about silver 1 ion? It's going to be +1. And over here, this aluminum ion, +3. And the silver, be 0. Okay, so which of these things is being oxidized, the aluminum or the silver ion? Which one is having its oxidation number increase? The aluminum, right? It's going from 0 to +3. The aluminum is being oxidized. So that's going to be our oxidation half reaction. We're going to take the reactant on the left and we're going to put what it goes to on the right. It goes to Al3+ aqueous. That's the oxidation half reaction. The silver is being reduced. It's going from 1 to 0. There's a reduction in the oxidation number. And so we've got silver plus going to silver metal. Any questions? So you identify what's oxidized and what's reduced, and you separate them. Now we're going to balance each of these with respect to mass and to charge. These are already balanced with respect to mass. There's aluminum on one side, aluminum on the other. But the charge isn't right. So we're going to balance the charge with electrons. Electrons are negative, right? So to balance this oxidation reaction, are the electrons going to be a reactant or a product? They're going to be a product. I'm going to need to add 3 electrons over here. So 3 negatives and 3 positives add up to 0, and the other side is already 0. Nothing happens with protons, so you can't say, well, what if I've added 3 protons over here? Well, that would be nuclear chemistry, and that's the next chapter. Then we look at the reduction reaction. So here's silver plus and silver. Where does the electron need to go, on the reactant side or the product side? It needs to go on the reactant side. So I need to add, this time, just 1 electron because I have a +1 charge. So silver ion plus 1 electron gives me silver atom. With me on that? So we balance each half reaction, and then we have to understand that the number of electrons lost in the oxidation has to be equal to the number gained in the reduction. if aluminum lost 3 electrons, somehow the silver has to gain 3 electrons. So what we're going to do, because here we have 3, and we can't make that any smaller, we're going to take this reaction and multiply it by 3. So what's really happening is we've got 3 silver ions gaining 3 electrons to form 3 silver atoms. So that's what we just came up with here. Now we need to add the half reactions together. You can add equations in math, and you can add equations in chemistry. So we're just going to add these equations together. So I'm going to get 3 silver ions plus aluminum plus 3 electrons, and that's going to give me 3 silver plus aluminum ion plus 3 electrons. But these electrons really cancel each other out, don't they? There was 3 on this side and there's 3 on that side. They're actually not floating around. They were transferred from one to the other. So we cancel those out. Another way to do that is to look at these equations that you're adding and say, oh, well, this is the same. Oops. This is the same on both sides. So those are going to cancel out. And so there's the equation that we end up with. And then we should always double check our work. Make sure that you have the same number of atoms of each element on each side. I've got 3 silvers on this side, and I've got 3 on that side. I've got 1 aluminum and 1 aluminum. That's mass balance. And then I need to check charge balance. Over on the left side, I've got a total of 3 positive, and on the right, I have a total of 3 positive. And so the charge balances as well. Total charge has to be equal on each side. It does not have to be 0. It just needs to be equal. Because this amounts to being a net ionic equation. There are spectator ions in there, but we don't know what they are, and it doesn't really matter at all. Any questions? So here's some additional guidelines for balancing with respect to mass. That equation just had silver and, what was it, zinc? No, aluminum. My short-term memory is just like gone. Oh, we were talking about chemistry? My goodness. But if we have hydrogen and oxygen in there, then things can get a little bit messy. And so these are the guidelines. First, you balance each half reaction with respect to all the elements other than hydrogen and oxygen. These reactions are occurring in aqueous solution. So we know that we have water present, and there are also tiny concentrations of hydrogen ion and hydroxide ion. And so we can use those to balance the oxygen. The next thing we do is we're going to balance the oxygens by adding water wherever it's needed. Then you balance the hydrogens by adding H+ ion. If it's in acidic solution, you just stop there and you're done with the mass balancing. If it's in basic solution, there wouldn't be hydrogen ions hanging out. And so we need to neutralize them. And what we're going to do is we're going to add hydroxide ions to each side and combine the hydrogen ions and the hydroxide ions to form water, and then cancel out the water molecules that happen on both sides. And we'll do some examples, and hopefully that'll be clearer. So let's do this one. Balance the redox reaction occurring in acidic aqueous solution. So we need to identify what's being oxidized and what's being reduced. So let's write oxidation numbers. What's the oxidation number for H+? It's the same as the charge. +1. And for Cr, 0. And H2, that's an element, 0. And Cr3 plus 3. Okay, so now we can see that the chromium is being oxidized and the hydrogen is being reduced. So I'm going to write two separate half reactions. So I've got H plus, and that's going to H2. And I've got Cr going to Cr3 plus. So first I need to balance with respect to mass. Is this first reaction balanced with respect to mass? Are there the same number of hydrogen atoms on each side? No, there's 2 on the right. So what I need to do is I need to put a coefficient of 2 over there. So it's balanced with respect to mass. Now I'm going to balance it with respect to charge. Here I have plus 2 charge on one side and 0 on the other. So I need to add 2 electrons on this side, because those 2 negative charges will cancel out the 2 positive charges. Now I'm going to turn to the other one, chromium going to chromium 3 plus. This one's already mass balanced. There's 1 chromium on each side, but it's not balanced for charge. There's a 3 plus charge over here, so I need to add 3 electrons. 3 plus, 3 minuses adds up to 0, and I have 0 on this side. They just need to be the same. Now I need to figure out how I can get them to have the same number of electrons. This is 2, and this is 3. So I'm looking for the lowest common multiple. So 6 is the smallest number that has both of these as a factor. So I'm going to multiply the top reaction by 3 and the bottom reaction by 2. So I'm going to take a different color and go through and do that. So 3 times 2, that becomes 6 electrons. And 3 times 2 becomes 6 hydrogen ions. Showing up okay? And 3 over here. So I distributed that. I'm going to scribble that out. Down here, multiplying by 2, I'm going to get 2 chromium atoms, 2 chromium ions, and 6 electrons. So I'm just multiplying each species by that number. Now I can add them together. So I've got 6 electrons on that side and 6 electrons on that side. They go away, cancel out. I'm going to write down what's left. Here they wrote the hydrogen first, so I'm just going to write the hydrogen first. You don't have to, but... So 6H plus, I'm going to throw my state symbols back in there, plus 2 chromium. So those are the things on the reactant side. And then over on the other side, I've got 3 hydrogen molecules and 2 chromium ions. And then I want to double check that everything's balanced. So I've got 6 H's here. I've got 3 times 2, 6 H's there. I've got 2 chromiums and 2 chromiums. And then I'm going to check the charge. 6 plus on that side, 6 plus on that side. Balanced chemical equation. Any questions? Let's do another one, because they're so fun. Balance the redox reaction occurring in acidic aqueous solution. What's the first thing we need to do? Oxidation numbers. Identify what's being oxidized, what's being reduced. What's the oxidation state, oxidation number for copper? 0. NO3 minus. We have two nonmetals here, and so we think of that order. Fluorine, hydrogen, oxygen. So oxygen gets to be -2. What's the nitrogen going to be? We've got 3 oxygens, they're each -2. That's a total of -6. And it has to add up to -1, so the nitrogen must be +5. And if you need to write that all out, you should. Just write it out. So copper 2+ ion, what's its oxidation number? +2. Over here we have NO2. Well, the oxygen gets to be -2. The oxidation numbers for the oxygens and the nitrogen have to add up to 0 this time because it's a neutral molecule. So there are 2 oxygens, they're each -2. 2 times -2 is -4. So the nitrogen must be +4. So who's being oxidized? Copper or nitrogen? Copper's being oxidized, and nitrogen is being reduced. Its oxidation number is being reduced, it's decreasing. So I've got copper going to copper ion, and I have NO2 minus, I'm sorry, that's NO3. NO3 minus going to NO2. So that first one is already balanced according to mass. So what do I need to do to balance the charge? Add 2 electrons on the product side, right? Now, the bottom one is not balanced with respect to mass. So what we want to do is we want to take care of everything but hydrogen and oxygen first. So the nitrogens are okay. I've got 1 nitrogen and 1 nitrogen. But here I've got 3 oxygens, and over here I have 2. I need another oxygen in the product. So I'm going to add water to balance the oxygens. So I'm going to add H2O. And now I have this one plus those 2. I've got 3 oxygens on each side. Next I'm going to add hydrogen ions to balance the hydrogens, because now I threw hydrogen into the mix. And so I've got 2 hydrogens on that side, so I'm going to put 2 hydrogen ions on that side to balance out all the atoms. Any questions? Now that the masses are balanced, the atoms, I need to balance the charges. On the left side, what is the total charge between the 2 hydrogen ions and the nitrate ion? +1. And on the right side, it's 0. So I need to add 1 electron here so that I have 0 charge on both sides. I need the same charge on each side. The numbers of electrons are not the same. Here's 2 electrons and here's 1. So if I double the second equation, then I'll have the right number. So I'm going to put a 2 there, and this becomes a 4. And that's not a good choice of color. Maybe this will work. That's a little better. Sorry, that's off the screen. There's 2 electrons over here. And it's multiplying all the coefficients by 2. And I'm doing that so I can get the same number of electrons on both sides. I've got 2 electrons on the right and 2 on the left. They cancel out. So I've got 4H plus, that'll be aqueous, plus 2 nitrate ions, that'll be aqueous, plus copper metal, and that's going to give me 2 NO2 gas, plus copper ion, plus 2 water molecules up the side there. Any questions? Yes.
So for the previous one,
Mm-hmm.
how come when the hydrogen was a plus and then it became 0, it's an oxidation? And then for this one, for the oxidation, why is it gaining 2? What, losing 2?
That was a reduction for the hydrogen and an oxidation for the chromium.